Hey everyone. I hope you like swimming because today is all about dividing. Swimming time. They say, whether you're religious or not, they say that even Jesus divided bread amongst 5,000 people. You've seen dividing everywhere, and guess what? Now we get to do it with polynomials. Polynomials! This week, we divide. So, I'm going to go over a brief overview of division, and because I know some of you could use a refresher. Also post a video going over division a little bit on Canvas. If you feel good about division, you can jump ahead a little bit, but if not, you can join me while I explain a little bit better, mostly about long division, because I know for a lot of you it's been a while. So let's dive into the basics. Last week, I had someone say they're a little confused about the difference of division and fractions. Well, they're actually the same thing. In fact, if you actually look at the division symbol, it's a fraction. It's just instead of having it be a fraction, it just uses dots. And then this is the number that goes in front, and this is the number that goes in the bottom. So in case you didn't realize that, that's why it looks the way it is and works the way that it does. So multiplication is you adding that number that many times. Division's a little similar, but it's how many times you can break up that number. So using the same example, we want to divide 24 into 3 bits. Well, if we divide it into 3 equal bits, that would be 8, just like we saw with the multiplication. 3 times 8 is 24, or 24 broken up into 3 parts is 8. Similarly, 24 divided by 8 would be 3, because if you broke into 8 equal parts, it would be 3. So that's how division in general works. So 20 divided by 2, 10. 15 divided by 3, 5. 45 divided by 5, 9. 828 divided by 6, say it with me. Actually, that might be a little more advanced for you. So what we can do whenever we have these bigger numbers is we can use what we call long division. And we are going to be using this with polynomials. So let's go over kind of how this works. Yeah, you tuning in? Yeah, it's going to get good. All right, so let's go back to that same example we have, 828 divided by 6. You're always going to put the second number or the number in the denominator first, and then the other number under this house. I forget the proper name. It starts with a V. Oh man. But no worries. I think in elementary school they call it the house, or they're like, put it in the house. So you'll put the number in the house. All right, so first we need to see how many times does 6 go into 8. And it goes into it once. And it has a remainder, or has 2 left over. So we put the 1 on top, representing the fact that 6 goes into 8 one time. And then we show that we have 2 left over, because when we subtract 6 from 8, we have 2. And 6 doesn't go into 2. That should always be the case. It should always be less than the number that you're trying to get to, because that means maybe you could have divided by a higher number. If that was, let's say, 8 again, then you can divide again, so it should have been a 2. But in this case, it is 2, which is great. All right, so now instead of seeing what can go into 2, we're going to bring the other 2 down and see how many times 6 goes into 22. And 6 goes into 22 3 times, which is 18, by the way. 6 3 times is 18. So you're going to subtract these and see what you have left to work with. And you have 4. So you're trying to think, or 6 doesn't go into 4, so we bring down our 8. Now we try to see how many times does 6 go into 48. 6 goes into 48 8 times. So 828 divided by 6 is 138. Again, I can post a video explaining this even more. I'll show you a few more examples though, so we can get used to long division, because we're going to start using it with polynomials. All right, Fozzie. So we're going to take 1,860 and divide that by 4. Yeah. All right. So we put our number at the bottom on the outside, and we put our bigger number on the inside. And now, let's see. 4 doesn't really go into 1, right? So I guess we'll kind of move a little more into our fraction. How many times does 4 go into 18? 4 times. 4 times is going to be 16. So if we take 18 minus 16, we get 2. That seems to be a number we like working with. Let's see if that pattern continues. So 4 doesn't go into 2, so we bring down our 6. And 4 goes into 26 6 times. You thought I was going to say 5, but it's 6. 4 6 times is 24. 26 minus 24, again, we got a remainder of 2. So then we see how many times does 4 go into 20? 5 times. So 1,860 divided by 4 is 465. Fozzie told me my audio wasn't doing too great. So he's here to help me with my audio. And he just really wanted to know, what is 4,920 divided by 5? Are you ready to find out, bud? Here, let's find out. All right, so how many times does 5 go into 4? You're right, it doesn't go into 4. That was super silly. All right, but it does go into 49 5 times, or 9 times, right? Can't think while you're squirming. All right, so now 5 times 9 is 45, and then we're just going to subtract. And I'm going to pause for 1 second. He did not like that. Anyway, so we have a remainder of 4 from doing that part. And now we're going to bring down our 2. 5 goes into 42 8 times. And then 5 times 8 is 40. 42 minus 40 is 2. We're going to bring down our 0. And 5 goes into 20 4 times. So 4,920 divided by 5 is 984. We solved it, bud. Woo! So up until now, all of our numbers have ended on good terms. But 5, usually when it's divisible, it ends in a 5 or a 0, right? But in this case, it ends in a 6. So I'm not really sure. What do you think's going to happen, bud? Yeah, I know you know. Yeah. But just in case they don't know, let's still do it, okay? So 5 doesn't go into 2, right? That would be crazy. But it does go into, oh, sorry. I was trying to put it on him more, but the camera slipped. There he is. Yeah. Yeah. All right. Sorry. I always get distracted whenever I film with him, which isn't much, but he's so cute. All right. 5 goes into 28 5 times. That's 25. And then if we subtract 28 by 25, we get 3. Oh my goodness. 3. 8 minus 5 is 3, obviously. And then we bring the 4 down. And then we try to think, how many times does 5 go into 34? Well, 5 times 7 is 35, but we can't get 35, so we go 1 before that. So 6. And 6 times 5 is 30. And then we subtract them, and we get 4. And then we bring the 6 down. 5 goes into 46 9 times, because that's 45. 46 minus 45 is 1. So our assumption was right. We were right. It doesn't go perfectly into 2,846. So this is what we, of course, call a remainder. So this is our remainder. So it divides 569 times with a remainder of 1. Or sometimes you'll see R1, or you'll see it as a fraction. So in this case, it's 1 over 5 because we're dividing by 5. So we're with this 1 right here, you're still trying to think how many times does 5 go into 1, but you don't have anything else you can bring down. I mean, you could make a little decimal here, I guess, and it's actually going to go into 10 2 times. So it actually is, or that should go up here. So it's actually 0.2, which is also 1/5. But for the sake of this, we're not going to do decimal answers. We're going to leave it as a fraction. It will make more sense when we get to the actual polynomial part. Hey everyone, we have another big one. 22,000. That's the biggest number we've divided so far today. 22,175 divided by 4. Now, we already kind of know that 4 should always have even number answers, right? Whenever it's a good multiplication. So we already know that we're going to have a remainder. So let's go ahead and see what happens, bud. Trying to keep it on him a little bit. All right, so 4 doesn't go into 2, but it does go into 22 5 times. So 4 times 5 is 20. 22 minus 20, we get 2. There's our favorite little divisible number again. 4 doesn't go into 2, but it does go into 21 again 5 times. Because again, 4 times 5 is 20. 21 minus 20, we get 1. Bring the 7 down. 4 goes into 17 4 times. And then that's 16. So 17 minus 16 is 1. And then we bring our 5 down. 4 goes into 15 3 times. Yeah, 3. And then, oh, does that sound like treat? It is a treat. Math is always a treat. And then we subtract that and we get a remainder of 3. So again, try to keep this into a fraction, but you'll see it written as remainder of 3, R3, or 3 over fourths, because again, we're trying to see how many times we can divide this up by 4, which would actually be 0.25, which you can see if we added a decimal here and brought that down. 30, 4 goes into 30. I don't know, wait, 0.75, oh my word. 7 times, and then that would be 28, and then that leaves a remainder of 2, and then, wait, 4 goes into 17, 22, and then, oh, this would be a 0 that you'd carry down, so 20, and then that would give you 5. So yeah, 0.75, but again, we're not going to do remainders, we're going to keep them like this. So yeah, fun stuff. So this slide is just to give you different vocab. So the number in front we call the divisor, and then the number inside we call the dividend. We already kind of talked about remainder, and then the number on top is called the quotient. So you can write this down if you'd like any terminology. But this kind of concludes our overall debrief on devising, and now we'll kind of jump into the main criteria. So today's main objective is to be able to divide polynomials. I have by long division and synthetic division. That is going to be the objective for the entire week. So today I'm going to start with monomials, and then we're going to do long division with mostly binomials, and then work our way to synthetic division with binomials. I know, it's exciting. And yeah, so I'm going to try to make it pretty straightforward. So today will be monomials, this will be tomorrow, and then this will be Thursday and Friday, and basically all will be Monday and Tuesday for the following week. All right, so this is the standard for if administration is curious, but you don't need to know the standards. So I just started with two very simple division questions. 3 divided into 6x plus 15y. You're just going to divide 6 by 3 and 15 by 3, and you're going to get 2x plus 5y. I'm hoping that's review. Now, where you might be confused is when the variables come into play. So, for example, if you look at the a squared divided by a and the ab divided by a, hopefully you'll follow this logic, but I'm actually going to break it down a little bit more into the next step. So, this looks scary at first, but it's actually quite easy. I'm going to kind of overcomplicate it for a moment, just so that you really see what's happening when I'm dividing by this. Well, first of all, whenever you have a denominator over a whole polynomial, you have to remember that that's dividing into each term. So while it looks a little more concise on the left, the right is really what's happening to the equation. And from there, we can look at it into individual pieces. So think about it as 4 divided by 8 and x to the 4th divided by x squared for the first bit. And 4 divided by 8 is 1/2. And x to the 4th is the same as x times x times x times x. And x to the 2nd is the same as x times x, right? So it makes sense that this would be kind of what's happening behind the scenes. And you can cancel 2 of the x's on the top and the bottom. I think we get canceling. We did it a little bit ago, and I think it clicked pretty well. But essentially, 4x to the 4th divided by 8x squared gives you x squared divided by 2. So again, 4 over 8 is the same as 1/2, and then we're left with only 2 x's. Now we're going to do the same idea, but with the 2x to the 3rd divided by 8x squared. Now, 2 divided by 8 is 1 over 4, and then x to the 3rd is the same as x times x times x, and x squared is the same as x times x. So again, we can cancel 2 x's from the top and the bottom, leaving us just with x over 4. That's a lot to take in for a second, but that's as much as I can kind of break it down to hopefully make sense of what's happening, which I'll discuss after I do the last term. All right, so we've made it this far where we have x squared divided by 2 plus x over 4 plus 32x squared divided by 8x squared. Now, I'm not going to do this one out because I think you get the fact that x squared divided by x squared cancels out. And then 32 divided by 8 is 4. So this would be our final answer. Now, to make things easier going forward, I want us to note that basically when we are dividing variables, it's subtracting. Similar to how when we multiplied last week, it was adding exponents, right? Well, this time it's essentially subtracting exponents. So if this helps, here is the quotient rule of exponents. Basically, you can subtract the exponents as long as the variables are the same. Now, normally we don't like negative exponents, so normally instead of having a negative exponent, you'd leave it in the denominator, kind of like you would with canceling out. Whatever is left will stay where it's left. I think we have 1 or 2 examples like that in the future, and you're going to see negative exponents briefly in this section, but that's only because it is implying that there's division, which I'll go into with tomorrow's video. All right, so here we have 2x to the 6th plus 24x to the 5th plus 30x to the 4th, all divided by 6x squared. Now remember, that's all divided, so really each piece is being divided. Now, all we have to consider is we can look at each piece individually. So 12 divided by 6, and then x to the 4th divided by x squared. Now, remember, you can subtract the exponent because think about it again, as it's 4 x's divided by 2 x's. So there's 2 left over the top. So this first term would be 2x squared. Oh my goodness. Wait. Oh, it was to the 6th? How did I mess up? I messed up here. 6 minus 2, 4. All right, so at least that's right. Now we can look into the second term. If I can get the blue going away. Oh my word. So 24 divided by 6, and then 5 minus 2, or again, you have 5x at the top, 2 at the bottom. You can get rid of 2 from both, and you're left with 3x's and 4. It's 24 divided by 6. Hopefully you see how I got that. If not, please feel free to ask a friend. I will post videos explaining it even deeper. I'm trying not to spend too long on it, so this video is not too long, even though I keep getting distracted by Fozzie. Hey. And then we're going to do 30 divided by 6, which is 5. And then we're going to subtract the 2 from the 4, and we get 5x squared. So that's your final answer. I'm hoping that it's clicking better and better each time. Now here we introduce another variable, which seems scary at first, but again, look at each as individuals. So we'll start with looking at it as the individual terms, but for this one I actually went a different approach. Yeah, so what I wanted you to consider is, let's just look at the numbers first, and then we can look at the x's, and then we can look at the y's. I know, he's waiting for his treat. I know, I did say it. All right, so 4 divided by 2 gives us 2. 8 divided by 2 gives us 4. And then 2 divided by 2 goes away. They cancel out. All right, so now let's look at the x's and the y's. You can either cancel those out and then go for the y's, or just think about it as like we did with subtracting the exponents. You're going to do 2 minus 1, because this is an invisible 1. 1 minus 1, because this is an invisible 1. 1 minus 1 here. 1 minus 1 here. 1 minus 1 here. 3 minus 1 here. And we are left with this. And now your zeros are going to cancel out. And your 1 is just going to kind of go away. And that is your final answer. Now, I don't know if I overcomplicated it, whereas you could have just done it from here and thought, okay, I'm taking 1x away here, and I'm left with 1. Both y's cancel out. Both x's cancel out. Both y's cancel out. Both x's cancel out. 1 y cancels out. And all you're left with is 2x plus 4 minus y squared. Fun. All right, similar idea here. I think this was the slide I was actually thinking of. Think about let's divide both of these by 3 first. So 27 divided by 3 is 9. 9 divided by 3 is 3. All right, now let's look at our a's. So A7 divided by A2 is going to be A5. A3 divided by A2 is just going to be 1A. And now let's look at our b's. So b to the 5th divided by b, that's just going to be b to the 4th. And same thing for the second one. I think that was a lot easier. So you can do it a lot of different ways. I think you're hopefully getting the hang of it. And some of these are even some you're going to see on your assignment today, like this next one. All right, so there's one like this on your homework assignment or your Connect Ed assignment, and you're going to do 8r squared plus r minus 4 divided by 2r. Now look at these as individual pieces. 8r squared divided by 2r. 8 divided by 2 is 4, and then 1r is going to cancel out on the top and the bottom, leaving you with just 4r. Now for the second one, an r is going to cancel out at the top and the bottom, but there's nothing to counteract with the 2, so it's actually going to be 1/2, because I I guess just think about it as there's an invisible 1 in front of the R is the best way to think about it. And then the last one, 4 divided by 2 is going to be 2. And then there's an R left in the bottom. There's nothing to counteract at the top. So we're actually going to leave it as minus 2 over 4. This should be minus 2 over 4. Sorry, I've been really busy this weekend preparing for my wife's surgery. Anyway, hopefully you caught my error before I even made it. All right, everyone. So this one's a bit of a tricky one at first. And you're going to have one just like this on your assignment. I just changed the numbers around. He doesn't like being a lapdog. So, do you want to help them, though, on this one? Okay. Tell them, what should we do? Yeah! Yeah, you did that with your nose. You did that with your nose. Okay, before you get too far ahead. All right. So, I think he's caught on to the space bar being the fun thing to press. So, as you can see, vt squared divided by 2v, the v's cancel out, and I'm left with t squared divided by 2. Now, 16vt and divided by 2v, 16 divided by 2, that's going to give us 8, and then the v's are going to cancel out, so all we're left with is 8t. Now, we're going to do 4 divided by 2, which is 2, but we have a t and a v left, and they can't cancel each other out. So we're just going to leave it as 2t divided by v. There is one very similar to this on your actual homework assignment or on ConnectEd. So this is another complicated one that you're going to have on the homework assignment or on the ConnectEd assignment. I keep saying homework, and I'm sorry about that. I guess it's because I'm home, right? This is my homework, I guess. Let's look at these as individual pieces. X to the third divided by 3x. Now we can't divide the 3, but we have 3x at the top, 1 at the bottom, so we're left with 2. So this is going to be 1/3 x squared. Similar, 7 divided by 3. 7 doesn't divide by 3, so we're going to leave that as 7 over 3. But we can cancel 1x on the top and the bottom. So we're left with 7 over 3x. Now, kind of similar, but we don't have an x to cancel out. So this is what I meant, that if it's something like this, you're going to leave the x on the bottom, on the denominator. So this is just going to stay the same, plus 5 over 3x. That one's a tricky-ish one, so see if you can catch it. I changed the numbers, or the letters, but it's basically the same question. All right, everyone, last example for today, and then please try some on your own. Let's look at these as individual pieces. All right, and then let's look at this first piece. 4a squared b divided by 8ab. 4 over 8, that's going to be the same as 1/2, or at least a 2 at the bottom. Now we have 2 a's at the top, 1 a at the bottom, so we're left with 1 a at the top, and then the b's cancel out. So we're left with an a at the top and 2 at the bottom. So it's going to be a divided by 2. The next one, the 8's, immediately I can see they cancel out, and the a's cancel out too. Here, let me do this for you. Now, b squared divided by b, that's just 1b left. So it's just plus b. Now, on the last one, we don't have 3 divided by 8. They don't really divide into each other. And then a doesn't have anything to divide into from the top. and then we have 3 b's at the top, 1 b at the bottom. We can cancel that out and get rid of one of these b's, and we're left with 3b squared divided by 8a. And that was our last practice problem. Alright everyone, that video was a lot longer than I intended. I think you still have time to do a lot of the assignment today. I promise the next videos will not be this long. I am sorry I got distracted by my amazing dog, but also it was just a lot to go over because it's probably been a while since you've done division. Take it slow. I'll post more videos if you want even more explanation. You can reach out too, and just try to get some of this done. And then I'll post the next video very soon, and you can start on that assignment once you get the chance. If you finish this one early, or once you finish this one, you can then watch that one and work on that. But I hopefully this was a good introduction to what we're going to be doing next. And I hope you're all doing well. I'm sorry I'm not there. Please still be good. Please try to avoid using your phone and try it on your own. Thank you. All right. From Foz and Mr. Fowler, we wish you the best. Bye.